I've heard a bit about quantum tunneling being used in electronics.
What's that?
I've heard a bit about quantum tunneling being used in electronics. This is probably one of those examples.
Yeah, this is not the video I thought it was, but we'll finish this one, then I'll find the video.
That actually reminds me of that making of the boy and his atom video that you pulled up.
Yeah.
How it manipulating atoms or molecules. Has anybody seen the video A Boy and His Atom? It's a video by IBM made using nothing but carbon dioxide molecules. They also showed a video of how they made the video. It's pretty interesting.
Oh, you can read French, right?
Oh, I'm not reading. I saw a video where where a guy or girl made a sentence with a few words that all sound like there.
There we go. earlier we dealt with that. Alright.
Yeah, you know, I've tried to throw in meso material just to fill in the gap, but we could get into driving the 4 quantum numbers. Well, the other 3, we've already done one, but, well beyond the scope. And that's gonna be more of, it's a really complex equation, and, when you've got a couple more years of calculus, we can solve it. So anyway, in essence there, because it is possible for a particle to show up on the other side if the other side is small enough. This is actually how you can go through walls. Because I am composed of particles which have a wave duality to it, it is possible for the particles to suddenly appear on the other side of a wall. Now, odds are way against it. And if you have ever run into things, you know that you tend not to go through it. But it is a non-zero probability. The other trouble is that observing it also what's known as collapses the wave function. So in the video, and we talked about it before, is that when you put the observer on one of the slits, suddenly it loses the it loses the wave properties and becomes a particle. So in order to appear on the other side of the wall, you would have to prevent from collapsing the wave function. So if I can collapse, so we get into the philosophical aspect, if I can collapse the wave function of an electron being shot through a double slit, then can an insect collapse my wave function? Can any living object prevent me from going through a wall?
What does it classify as an observer?
And that's a fundamental question and I don't think physics has really come up with an answer to that yet.
I think that would follow-up question, why does an observer collapse it?
I don't know if I have a good answer for that.
It doesn't make sense to me, but,
That's quantum. I'm sorry.
okay, fair. I don't know, I just don't see why knowing where the part, or which slit it goes through is gonna change the output. Seems weird.
Yeah, I don't have an answer for that one, but it does, I mean, the experiments have been done. It does make the wave function. The wave function is about probability, and as soon as you are observing it goes through the slit or it doesn't go through that slit, then suddenly the probability becomes either 1 or 0 at that location. So you can look at it as there's still an area that is completely unknown, and that someday somebody will potentially figure it out. The other way of looking at it is that's just the way nature works. And it's not for us to wonder why, it's just for us to, not do and die, but all we're doing is just modeling the way nature seems to be working. Starting with just some really absurd logic that just happened to work out.
Couldn't the wave, the thing of waves just be, the mathematical side of it? Everything, they actually are particles, but, the wave part of everything is just how it's expressed mathematically.
So ultimately, math is just a model. I will agree with that. However, the fact that I can send the electrons at the target, not observing it, and it does exhibit wave behavior, would indicate that there is some legitimacy to that the particle does act like a wave, that it's not a particle at all.
What if it is just a particle and that wave behavior is just, it's just behavior, it's nothing more than how the particle acts? Or, if that makes sense. I mean, I don't
How would
know.
you distinguish between the way the particle, right? So your argument is, or you're speculating, wondering if it's still a particle but has wave properties. Is that basically it?
Well, the wave properties are just how things would show up on a graph. And it's literally just a particle. We have photons, their behavior the wave-like behavior of photons is just how it appears on is just a mathematical graph of.
Except you saw the interference patterns with the light itself. I mean, the fact that, and I'm pointing to where we do in the experiment.
But isn't wouldn't those wouldn't that pattern just be where all of them are, isn't that just where they hit as opposed to?
It is where they hit, but why, in the experiments where they've shot a single electron at the double slit, and in the video right there, that you send the particle in, they express it as a wave, it goes through the double slits, and then when it gets to the wall, it's being observed, so it collapses to a single point. Then you send the next one through, and it collapses to a single point.
I thought that was just theoretical. That was just theoretical.
No, that they have done that experiment.
Oh.
That's part of the Davis-Grummer experiment.
And I'm not sure.
It really does seem to be that, one, nature does behave like a wave sometimes, like a particle sometimes, and whichever one you're looking for is what you see, for the most part. I mean, so when that's oversimplification. And that this idea of the wave function to describe the particle describes the probability of where an object is if you're looking for it as a particle. But if you're not looking, then it describes the wave itself. I think I'm safe with that.
Yeah, I'm not sure.
It does get bizarre.
Yeah, it's something that I would just accept as part of life, and some things are way too over my head to question or understand.
But ultimately, the fact that we have these electron tunneling microscopes that work. So, yeah, I keep going back to, we have something that works, so.
That's kind of how I am too.
There's a hypothesis, they've tested it, the test supports it.
Yeah, if you can make something out of a discovery, then yeah, it's true. Engineering is just taking taking science and finding a use for a scientific discovery. Like the tunneling microscope.
Yep. Or quantum computers.
Yeah, do you know anything about Spintronics? I've tried looking it up, but the stuff goes way over my head.
So these are electronics based upon quantum spin?
Yeah, that's what I think it is.
Okay.
If you know anything about that.
Not a whole lot. I mean, we derived the first quantum number, that was when we did the Bohr model of the atom. If you go farther, and that's the part where I just sort of stopped myself, but you end up with 4 quantum numbers that are needed. You basically use Schrodinger's equation on a hydrogen atom in order to describe, basically to solve it. There are 4 numbers that you need to know. One is the value of n, which is the orbital level. Then there's m sub L, I think those are backwards, and then s, which is spin, it's the smallest thing. So the electrons, for example, are spin up or spin down. Matter of fact, a lot of particles are, more specifically, electrons are spin up 1/2, spin down 1/2.
That's something you're not familiar, that's something that you don't understand as well as you.
Well, that's true for pretty much anything, but the spin of an electron, if I have 2 electrons basically with the same first 3 quantum numbers, the 4th quantum number needs to be different. And so that's why there's 2 electrons per orbital level. It was badly worded. It's been a while since I've done the chemistry side of it.
If you don't understand it, that's fine.
When you are looking at, my understanding of quantum computing is that basically they're looking at, ultimately it's all 1s and 0s. So you can represent the spin up as a 1 and spin down as a 0. And so now if you can manipulate which way the electrons are spinning, you can basically store information at the electron level. So that's my understanding of quantum computing. The trouble, at least when I was in grad school, the trouble that they were having is that a stray bit of radiation coming through can quickly change the direction of spin. And so, presumably, I think they've gotten past that. And I don't know if it's through shielding or through redundancy.
Say through shielding, most likely. I'd say shielding, probably. Make more sense. Cheaper, probably.
Probably would be.
Yeah.
Probably still some redundancy in there also, but I said.
Yeah.
Surrounded with metal. So anyway. Yeah, I've got nothing else, so, you got test on Thursday?
Oh, it's Wednesday.
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 Wednesday. That's right, today's Monday. If you show up on Thursday, I could consider you again if you want.